Good afternoon. So just to know who has experience in running virtualized networking functions like vSwitch or vRouter on a server? Thank you. Who actually use today SmartNICs on the network? Thank you. Who knows what is FPGA? Thank you. So I'm going to speak today on FPGA and data processing on FPGA, and actually more precisely on running networking and security functions on FPGA to accelerate server networking performance. So for those who don't know what is FPGA, so FPGA is essentially like a CPU, but is targeted to handle parallel processing, therefore best suited to run data processing versus CPU that is best suited to run applications. So, so what we see is the huge growth in data usage on the network. This is mainly because of peer-to-peer communication, cloud activities, security, social media, social networks, and all this kind of stuff, which actually result with explosive growth in data usage. Now, the main problem in this growth in data usage is actually the latency, which is associated with running virtualized software, authentication, and security. So the main, so because of the need for more data usage, there is a need in the network for. This is why all the operators today build 5G network in order to generate more bandwidth to the user, and this also results with explosive growth in the data center and latency and many other bottlenecks that need to be solved. Therefore, the industry pushed the data centers closer to the users, means to the edge of the network. And we can see this in this slide. We see the anticipated growth in the edge data center market from now to 2024. Where main application or main use is IT, telecom, co-location. Actually, co-location means that someone leases a building and offer space to other operators, other data center provider to put their equipment on it. So this is so essentially also co-location is also meant to deliver IT and data center and cloud services, same as the IT and telecom section, which is here in this slide. What we also see is plenty initiatives in the telecom and in the edge of the network. This starts from Amazon cloud front, which is edge services from Amazon, Azure IoT Edge. Azure IoT Edge is a service that serves Internet of Things, and also CORD. CORD is an initiative by the bigger telecom providers that actually try to re-architect the central office as a data center. So the main application in the edge is actually IoT aggregation. These are broadband gateway, mobile gateway, security gateway. These are the services that we need to support in the edge of the network. To understand the environment, just go back a bit to see what are the networking equipment that someone needs to deploy in the data center. So first of all, top of the rack switch, you need to have on each rack You need to have a router to connect between the rack, and you need to have a router to serve the virtualized environment like OpenStack. And in addition to that, you need to have a router towards the network. So on top of, other than the servers, there's plenty of other networking equipment that needs to be architected and deployed in the data center. Now, when we go to the cloud environment, it's more complicated. Why? Because in the cloud environment, we need to have additional gateway, a gateway for the virtualized software, which is called NFVI. So in the cloud, we need and when we want to deploy a data center with direct connectivity to the access network, now you need to serve mobile users, residential users like broadband connection, business users. Each one comes with different protocol. For example, mobile comes with a GTP protocol. Broadband runs with PPP. Different kind of sessions. No one knows how to talk with each other. It means if you want to connect IoT, then also plenty of different protocols. So when you get this kind of traffic to the virtualized software, now situation become tough because you need to classify all those different kind of protocol, send them to a different VNF, different machine, different CPU to run the right application, doing load balancing. And at the end, also, when you serve the customer and traffic goes to the customer, you need to have per subscriber SLA and quality of service and monitoring. And then this requires additional equipment. But the main problem with the edge is that you don't have space. You need to rent a space in a co-location environment. There is no enough power to put all the equipment that you usually use in a data center. Therefore, what we propose to make it simple, we do actually a router on a NIC. So if you anyway use a network adapter in your server, we also deliver within the network adapter router functionality, which eliminate the need for external equipment, eliminate the need for router for running OpenStack environment, serve as a gateway to the NFVI, means all the traffic that comes with different kind of protocols, terminate protocols, send different applications to the right virtual networking functions, and doing load balancing, and the traffic goes out from the network or from the servers out to the users, perform per subscriber SLA and monitoring. Now, if we go and look at the environment, not on a specific server, populating such kind of a router on a NIC actually enable you to connect many servers in a daisy chain and doing switching between VM to VM, support complete virtualized environment, such that you can switch traffic from one VM in one server to another one, only with this kind of router on a NIC without the need for external routers and equipment. And this actually saves a lot of space within the data center. So other than saving space of external devices like routers, what you actually save is on CPU power. Because when you run this kind of solution, we actually accelerate the networking and security appliances using minimal amount of CPU's core, because all the data paths, all the functionality runs on the FPGA NIC, and on the CPU, you just need to run the applications. So the solution, what we provide is solution on using FPGA. FPGA, as I mentioned, is like a commercial off-the-shelf programmable platform that is being used in many different kind of applications. And therefore, when you go and deploy solution with FPGA, it's like the same as you deploy CPU on a server. and that can be simply customized to deliver different kind of solution in different kind of environment without the need to design new ASICs or without the need to run proprietary hardware equipment on your server or on your network. So you do with this FPGA, it's open, as I said, it's programmable. We're doing all the data pass functionality on the FPGA. No need to run it on a CPU. And it's not only us doing this. What is important, that we are doing something which is in line with the tier 1 cloud providers. And if you talk about Microsoft, Amazon, and Intel, all of them use FPGAs on their NIC to accelerate and to stop burning CPU cores for something which they are not used to do. CPU better to use an application, and on FPGA they run all the networking and data pass functions. So this is our FPGA SmartNIC, full router functionality, including security offload and IPsec, and also accelerate VNF functions and reduced dramatically the amount of core needed to run virtualized networking functions like virtual switch, virtual router, and other. What is also nice with this kind of solution that the programmability is not just in the functionality, but the programmability is also on the interfaces. If you go and deploy and run with this kind of network adapter, you simply need to have a single card, one stock. We can download onto the FPGA different firmware to support different interfaces. It can be 8 ports of 10 gig, 25 gig, 40 gig, different kind of interfaces, but you maintain a single stock. You don't need to maintain different stock for different cards and solutions. It's a fully programmable platform that handles the data, because the FPGA used to handle data. So a bit about Ethernity. We are 15 years in business. We design a unique networking and security technology that enable us to fit into low-cost FPGA and deliver full programmable solution and compare that to the functionality and price of ASIC. It's covered by multiple patents, and we deploy this technology at more than 500,000 platforms worldwide, which connect 100 million subscribers. So we took this technology and implemented on this network adapter. So we run the code on the FPGA. The NIC is commercial off the shelf, is actually can be installed on any standard server, and all the appliances running on top of that. So today we also deliver to our customer complete network appliance like a router or a VPN gateway, all run on a fully programmable platform where the hardware is also programmable. So to summarize, I suggest you to stop burning CPU cores and move to use FPGAs in your data center and save lots of power, cost, and space. Thank you.